Lesson 8.4 is called the Moivre's Theorem, and we're going to look at powers of complex numbers. I will not ask you any questions about the roots of these complex numbers, so we're going to mainly focus on powers of complex numbers. First of all, when we take a look at what the theorem is saying, it says that when you have any complex number in the polar form of r times cosine of theta plus I sine of theta, this represents a complex number. Whenever you want to raise this complex number to an nth power, when you want to find the equivalent to this, you can simply just raise your r to the nth power, and then you can multiply the angle by n. It will be the same thing as raising the complex number to the nth power. So instead of cosine theta plus I say sine theta, they might simply use cis theta. So in simple form, if you have r cis theta to raise to an nth power, all we have to do is take this number and raise it to the nth power and multiply the given angle by n to find the equivalent expression. Let's take a look at some questions that I put on the homework. The first question is, if we have 5 cosine of 30 plus I sine of 30, this is a complex number and we're trying to raise it to a power of 3. According to the theorem, all we have to do is first, we're just going to take our R value, which is 5, and raise it to a third power. So 5 will be raised to the third power. Here it is. And then it will be 125. And then the angle will be multiplied by this number. So the original angle is 30 degrees, but now we're going to multiply this angle by the given power. So the new angle will be 3 times 30, which is 90. So this is the answer in polar form. When you raise this complex number to the third power, the answer will be 125 parentheses cosine 90 plus I sine 90 in polar form. But if we need to convert this back to rectangular form, we are going to just plug in the values for cosine of 90. Cosine of 90 is equal to a 0. Sine 90 is equal to a 1. So that makes this part to be 1 times I, which is just an I. And when we multiply it by 125, the expected answer for this first example will be 125I for these given numbers. Second example is pretty same, very, very similar. The difference is we're raising it to the 10th power this time. So the question we have is cosine 45 plus I sine 45. Since R is missing, we will default select it as 1. When there is no number different than, when there is no number here, we're going to assume that R is 1. So that means we will have to raise 1 to the 10th power, and then the original angle 45 has to be multiplied by 10 to find the answer in expanded form. So 1 to the 10th power is still a 1, and then when you multiply 10 by 45, your new angle will be 450 when you raise your complex number to the 10th power. Now, since 450 is more than 360, I will subtract 360 to find the coterminal angle. So when I subtract 360 from this, it's the same thing as, its coterminal angle is same as 90 degree. So when we plug in cosine 90 is a 0, but sine 90 is 1. And then when you multiply it by 1, this will be the expanded answer for the second example. For the third example, it's pretty much the same question, but they just use the shortcut of cis for this for cosine plus I sine version. And the R value is 3, and we're raising it to the fourth power. So the first step is 3 will be raised to the fourth power, which will become 81. And the angle 45 will be multiplied by 4, which makes the angle to be 180 degrees. So the answer in polar form will be, when you raise that complex number to the fourth power, the answer will be 81 times cosine of 180 plus I sine 180. Now, when we need to change this back to the rectangular form, cosine 180 is -1, sine 190 is 0. So 81 times -1 will just give us a -81 for this example. Now, another example from the homework is, if we have 3 minus 3i and we're raising it to a third power, first, since this is in rectangular form, the theorem will not apply until I change this back to the polar form. So the theorem that we studied at the beginning of the lesson, this only works if the complex number is in polar form. So when we look at this homework question, in this homework question, given problem is not in polar form. So first, we must convert it to a polar form to apply the theorem. A value is 3, B value is negative 3. So to calculate the R value here, you will have to square the 3 and square the negative 3, add them up, take the square root. So the R value will be for this complex number 3 root 2. Then we have to find the associated angle with this complex number. So tangent of theta is negative 3 over 3, which is just negative 1. And then the angle whose tangent value is equal to a negative 1 and its x value is positive, y value is negative. It's only possible in the quadrant 4, so the expected answer is 315 degrees. First, 3 minus 3i will be expressed as 3 radical 2 cosine of 315 degrees plus I sine 315 degrees in this line. Now we're raising it to a third power. So this 3 root 2 will be raised to the third power, and then the angle will be multiplied by 3. So this is what we're going to get when we raise this complex number to the third power by applying the De Moivre's theorem. But now, uh, this question, they want the answer in rectangular form, so we still have to calculate the cosine of 945 and sine 945 and plug in the values. And then first thing the book does is, because these are more than multiples of 360, so you can just subtract 720 to find the coterminal angle. After you find the coterminal angle, you must find the reference angles if you're not going to use calculators to evaluate these values. And then cosine 225 is negative root 2 over 2. Sine 225 is again negative root 2 over 2. When you plug in these values into the expression, root 2 times root 2 is just 2. And then when you divide it by 2, they cancel out and you just get 54 on the first side, but it will be a negative number because your cosine value is a negative value. And when you multiply 54 root 2 by this number, positive times negative is still negative. Again, root 2 times root 2 is 2. When you divide it by 2, they cancel out and you just get 54i here as an answer for this question. The last example we're going to go over under 8.4 is if we have x cubed minus 125 equals to 0. And actually, when I said I will not ask you the questions about roots, I was wrong on this. So I'm taking it back. Here, guys, we will have the roots example at the end of the homework. So after we find the powers of the complex number, the last example we have of the homework is finding the roots of the complex numbers. So when we have any question like x cubed minus 125 is equal to 0, we will add 125 to each side, and then our equation we need to solve is x cubed is equal to 125. So basically, we're going to take the cube root of 125 to find the x. But first, we're going to change 125 to this form, which is r times cosine of theta plus I sine of theta. So here, 125 squared plus 0 squared, because this is a plus bi format, and then the imaginary part is just 0 because there is no I showing up. So that makes the r value to be 125. Then we have to find the angle associated with 125. And then the angle associated with 125 is 0 because we have pure real part of this complex number. So 125 is the exact same thing as 125 times cosine of theta plus I sine of theta. Now, whenever we need to find the nth root of this equation, we are going to apply a formula like this. So nth root of a complex number will be calculated by finding the angles associated with this. The angles will be calculated as using this formula, the original angle plus 360 times k over n, and k will start taking values from 0 to all the way to 1 minus n minus 1. In this case, n is 3, so we want to find the cube root of 125. So that makes the n value to be 3. So that means we're going to use 0, 1, 2. So we will always use one number less than our n value. So the first angle, because the original angle is 0, and then the first k value we're going to use is 0, and n will be 3. The first root is going to get the angle of 0. For the second root, k value will be 1, n value will stay 3. So we're going to still apply the same formula. Original angle is 0, but we need to now add 360 times 1 to the original angle, and then we will divide it by 3. And then this is what the second complex number will get as an angle. And then when we have k equals 2, we will have 0 plus 360 times 2 divided by 3, and that will be equal to 240 for the third root of this angle. So first, root is going to have 5 times cosine 0 plus I sine 0, because cube root of 125 is just simply a 5. That's how we get this 5 value here. And then angles will be calculated using this formula. And then, therefore, this question is going to have three solutions, because we're trying to find the cube root. First solution is 5 times cosine theta plus I sine theta. Second one is 5 times cosine 120 plus I sine 120. And third one is 5 times cosine 240 plus I sine 240. Good luck with the 8.4 homework.